Oh, hey there everybody. We're going to do a lesson today on porosity, permeability, and retention. And my son has gladly volunteered to be my director here. So he's filming this process. So we're going to focus today on porosity. Well, porosity has kind of the word pores. So what that's talking about is these spaces that are in a rock or in soil that's between the sediments or grains. So let's imagine we had two tubes, tube A and tube B. And in tube A, we filled them with large sediment, such as pebbles. And in tube B, we filled them with small sediments, such as sand. Both containers are the same size. Let's say they're 1,000 milliliters. And both containers are what we would call filled with sorted sediment, which means every sediment is uniform shape and size. So everything in here is a round pebble, and everything in here is round sand. All right? So we would call these sorted. If they were mixed, we would call that unsorted. So what we want to do is figure out what's called porosity. That's the percentage of pore spaces that are in a rock or inside soil or in the ground. So the way we would do that is start to pour water into these. So if I started to pour water in, this blue is the water will fill all these little pore spaces. And the same thing would happen here. The water would fill all the spaces between the sediment. You get the picture. I'm not going to color in every one of them. So let's say I started pouring water in here until the water reached the top. Let's say I was able to pour 500 milliliters of water in here. All right? So that water filled these pore spaces. My question is, how much water would I be able to pour into the smaller sediment? Do you think I'll be able to pour more than 500, less than 500, or exactly 500? Alex, you have a guess?
Less than 500.
You think less than 500?
Mm-hmm.
Well, that's a good guess, and that's what most people will say. Why did you say less than 500?
Because there are more, so there's less spaces.
Since there's more sediment here, you think there is less spaces. But actually, the spaces are just smaller, and there's more. Here, there's actually less spaces, but the individual spaces are bigger. So actually, the answer is the same. Exactly 500. All right? Because, yes, these are bigger pores, but there's less of them. And here, these are smaller pores, but there's more of them. But when you add them all up, they are equal. So this actually has equal porosity. Okay? So now we're going to actually try to solve porosity. So porosity is solved by an equation. You take the amount of pore spaces divided by the total volume. Well, here I told you the total volume. So that's my denominator. So here we have 1,000 milliliters. And how did I figure out the amount of pore spaces? Because the water filled the pore spaces. And that took 500 milliliters. So how much is 500 of 1,000?
Half.
Half. Good job, Alex. So if we take half as a percentage, that means the porosity is 50%. All right? And both of them would be 50%. Now, not everything is 50%, but in this case, it is. All right? So what am I going to go over next? Well, what if I took both tubes and I poured them into a third tube? So I took both and I poured them into another tube. So I mixed them up. We would call that unsorted. So if tube C is unsorted. So unsorted has a lower porosity. Because what happens is the small sediment will clog up the pores. Right? So instead of water being able to fill those spaces are already filled. So there's less pores. All right? Now what's another factor that can affect porosity? Shape. So here, everything's perfectly round. And here, things are flat, like flat bricks. And what the flat bricks would do is kind of block the holes that might be there, like a really bad Tetris player. Right? Now, Alex, I don't know if you've ever played Tetris, but if you ever played Tetris and you get that one long one that buried the pores, then you can never get to that one pore. So if they're really flat, the pores might not be filled or blocked, or it just decreases it. The shape of a round sediment kind of naturally forms a pore. So in this question, which tube do you think will have the greater porosity? I kind of already answered it. Too bad. All right. Next page. All right. So now we're going to go into what can affect porosity. I already just went over the three major ones. So how does particle size affect porosity? Is there an effect or no effect, Alex?
No.
No, very good. You paid attention. See? If it was large or small, the porosity was the same. Okay? So if I was to draw a graph, it would be a flat line. And I'm going to write down no effect. Okay? How does sorting? So on my x-axis here, that side's unsorted and that side is sorted. So this was unsorted. So there's a low porosity. And these two were both sorted. So this would be, the way it's worded, a direct effect. So if the sorting increases, porosity increases. How does shape affect porosity? Well, the rounder, the more pore spaces can get created. So that's another direct relationship. I have one other that I forgot, and it is packing. This is hard. Packing, porosity. So Alex, have you ever packed your own suitcase?
Yeah.
If you want to fit more clothes, do you make it more packed or less packed, the clothes?
Less packed?
So you're going to be able, if it's less packed, is there more in it or less in it?
Oh, more packed.
You want to make it more packed. Very good. So if you make it more packed, what's going to happen to the air that's between the clothes?
There will be less.
Be less air. So if it's more packed, there's less pores. So if packing increases this way, porosity decreases. All right? So that's why if the ground is really packed and it rains a lot, you will get puddles. All right? Because the water can't enter the pores anymore. All right? So these are the major factors of porosity. All right? Size, sorting, shape, and packing. All right? If you have any questions, feel free to email me. Great job, Alex. Bye, class.